So appreciate everybody for turning up in the session. I was actually shooting for the longest session name. And there's even abbreviations within that. So if I expand those, it's really a small, like DMZ, Colo, like really long name, right? So I'm Jim French. I'm a distinguished systems engineer in our large enterprise kind of segment. This session kind of spun out of some work I was doing with some large banks. So we'll cover through. Now, how many people, because there was a naming thing originally, how many people signed up and just saw like a Nexus session? So a handful. So that was maybe a month ago or something like that. So the original intent was, and I'm just sort of level setting expectations. If you want to run out of the room, that's fine. So the original comment or session was like a Nexus service stitching fabric. And that absolutely is applicable. This is the use case of a service stitching fabric, which is Secure Agile Exchange. So another polling question so I could kind of gauge. Has anybody heard of Secure Agile Exchange who's not a Cisco employee? Yeah, a lot fewer. So, and probably maybe from me, but so it's not widely known, but it's a way, like one way to summarize it. So we're going to spend some time on what it is, and then we're going to talk about the infrastructure that sort of builds it. But it's essentially an attempt at creating a repeatable way of connecting things of different security levels, right? So when you take A and B and you want to connect them, and they're not both your company, like a WAN to a data center, typically you have to do some kind of security, and it's like how can we, and increasingly you're more externally connected, so how can we create a repeatable design that's virtualized, orchestrated, and automated of connecting to external things? I mean, that's like the sort of premise of it. And then what are the fabric services required to implement that? So that's kind of the high-level background. Oh, turn off your phones. It's a good thing they stuck this in my session. So we'll approach it in this manner. So choosing the network topology. This is basically covering. There's a huge change going on right now, which is people putting applications and data in public IAAS. SAAS has already kind of leaked out, but what are the implications to my enterprise network topology from applications and data moving to public IaaS clouds? And how does that going to change? And then how can we build that new architecture so that it's flexible, agile, secure, repeatable, all that stuff? But it's first choosing the right network topology, then identifying the problem we're trying to solve in this new world with these new requirements, and then creating patterns around those. So usually those are service chains, which gets to that original session name. So how do we create repeatable service chains and services to connect things at different security levels? And then looking at it from a global topology perspective. So first we'll look at one like a hub, and then many of those globally connected with a core. Because what's happening is sort of the cores today are between all our data centers. And in the new world, the core kind of gets rooted potentially in a carrier neutral facility, which is another good question for all of you even to see, which is how many of you have a presence, well, how many are enterprise? First question, okay, most. And then how many of you have a presence in a carrier neutral colo facility already? So maybe like 15, 20%. So we'll talk about that and what the advantages, disadvantages are. And then we'll talk about the technology, which is how do I virtualize, how do I do the fabric, how do I orchestrate and automate this stuff, put it in a service catalog, which is a journey, which is the last part. It's like how do I get to this place? And so choosing the network topology, some of the customers have already done this, some have not. Cisco IT, I don't know if the session's here, but in Berlin it was. We've done this thing called CloudPort. Right? And we've gone to carrier neutral facilities, and they become the ag layer for multiple clouds, right? And we've done it physically. What we're going to talk about is doing this sort of carrier neutral facility infrastructure virtually, but anyone that's already done it has probably done it with physical infrastructure, routers, switches, switches are always physical, but firewalls, load balancers, and all those things. So, this is what we've been building for years. The apps and the data are in a data center, and we called it center because it's at the center. It's at the center of the universe. All the networks are rooted in the data centers. And so topologically, this is what we've built, right? And over time, some of the apps have leaked out to the public cloud as SaaS, not necessarily public IaaS. So we had some banking customers initially and others now coming to us and saying, you know, which is an extreme approach, but we're going to close our data centers and put everything in the cloud, right? And we're going to do this in 5 years. And not only are we going to be cloud first, we'll be cloud all in. And that became like a way I started profiling customers yourselves, and I try to put you in a bucket, but then I realized this profiling is not appropriate, even in IT. But I tried it at first, because that's what we all do to try to simplify things. And so there's private first customers, which, you know, if given a choice, they're going to put it in their private data center. They're usually more cost conscious, and they'll go to public cloud for burst only, that kind of thing. And then you got your cloud first, which is, you know, if they're going to deploy a new application or replace an old application, their decision tree is public SaaS, public IaaS, private data center off the shelf, and then private data center custom, right? So that would be, you know, public cloud first, and then public cloud all in is not only am I going to be public cloud first, but I'm also going to spend money on lifting and shifting applications to the cloud. And it's usually a lot of money because I just want to not be in the data center hosting business, right? So I started applying those profiles to customers and then tried to pick the right approach, which each one. And then I, you know, started working with large conglomerate or multiple business unit customers. And what I realized is large customers will have a business unit in all three categories, right? So then how do you end up, right? So the ones that said they were going to be cloud all in, they think this is where they'll be in 2020 or some year that they pick, you know, just arbitrarily the business picks it. Usually IT doesn't believe it. The business, you know, wants it, right, for agility or whatever reason. So this is ultimately where we're, you know, they think they're going to end up aspirationally, and it may be where they end up, but it's going to be a journey. And during that journey, whether the customer's public cloud first or all in, this kind of network topology makes sense, right? And I'm looking at a single cloud, a single internet, you know, everything's simplified here, but it's taking everything, terminating in it in a carrier neutral facility. Later on I'll make the analogy, but I'll do it now, which is, you know, that colo is like the FedEx Memphis. You send everything to Memphis and everything's one hop from Memphis. So, you know, you think of it that way, like airline wise. And so they'll end up, and these percentages don't have to be exact, but you got a third of the apps in a data center, a third of the apps in public SaaS, and a third in public IaaS, and you have this, you know, hub as an on-ramp to any of these application hosting environments. That's where we're going to put the service stitching fabric, is in that little middle section, right? So that's where the fabric comes in. So if you're private first, what we're doing is building a organized, because we're going to create standards and have governance, an organized, virtualized, orchestrated, automated DMZ. And for the private first customer, they may be doing some development in Amazon, but they're not production in Amazon or Azure or whatever cloud. So it's usually a VPN connection, not a big deal, out of the private data center and into that cloud. It looks something like this, but we're going to create repeatable connectivity models in this DMZ infrastructure, which will include network security, telemetry, and service assurance. That's what we are going to create repeatable connectivity models for anything that we connect to. And we'll get more of that later. Now, then it comes to the question of, do I do direct internet access or not? And so from a branch, if you want to go straight to SaaS, do you want to backhaul it through your data center? That's a suboptimal path. So doing direct internet access out of the branch will provide a better user experience if you're terminating all your networks in your data center, right? So that's why the dashed lines are there. If I go to the colo model, I do that same connectivity infrastructure that's going to be virtualized, orchestrated, automated, and you guys will get tired of hearing me say that. In the colo, based on generic compute, you know, dynamic. But now, if I choose a colo that actually has the clouds that I'm consuming in it, so you can go to Peering DB or, you know, Equinix has a service for this. It's choose the colo CNF, whatever you call it, that has your AWS, your Azure, your Salesforce, et cetera, you know, in it. Now, do I need to do direct internet access at the edges to get a better experience to my SaaS? If all the traffic's going to the same place anyway, right? So rather than putting security, content filtering, and all that stuff in the branch, when the traffic's going to this same place, because just imagine the bubble for the cloud and my Salesforce are all in the same place. So I have the option of centralizing all that stuff in the colo and just doing direct to the colo because Amazon, Azure, or Salesforce, all those guys are in the same place. Does that make sense? And you can go to PeeringDB, and it really comes down to you want to optimize the PeeringDB.com. Sorry, it's a website. Is that? Yeah. So you can go. Like I can go type in OpenDNS and find out all the pops for OpenDNS. So if you're using OpenDNS for your for internet access security, you want them to be in this colo that you choose. If you're using Salesforce, you want them to be in there. So you can validate the presence of all the clouds you consume to be in that POP, and then you choose that one, and you terminate your WAN, like we're showing here, in that POP. Does that make sense? Have you guys it's like an internet, what BGP AASs and things are in, what places. So if you ever get to this place of, so you're a cloud all-in customer, it's 5 years later and you've evacuated your data center because that was your goal to be more agile or whatever, you can take what you've built virtually, virtualized, orchestrated, automated, and put it into the transit VPC inside of an Amazon. So if you're single cloud, that might make sense. But if you're multi-cloud, now you're building these things in many clouds. But we'll talk about what it is. But you could turn it into a transit VPC. And we already have an offer for transit VPC with our CSR. That is, if you want to go straight to the cloud, it'll do inter-VPC routing at 10 gig rates, and it's automatically configured through Lambda. Right? So that it's a viable thing. Then we just add security to that transit VPC. Now we got a secure Agile Exchange VPC potential, right? So that's that. And that, that's like you're living in the cloud at that point, right? So when I started working with customers, the initial thought they had was an SD-WAN kind of thing. It's like, hey, we're just going to connect all our branches to the clouds and all our partners and customers to the cloud. Everything's going to go to clouds. And the internet is my network, and there's VPN tunnels running everywhere that are encrypted. So we're going to talk about that topology and what the downsides are. But this is just a set of slides that I'll run through quickly, which is really, what are the interaction types that we need to consider when we're building out, this hub. And so this is really, I've been using this for like 10 years. And it's, an interaction is defined as an employee on a device in a place, crossing a network, accessing an application that presents data. That's, soup to nuts, consumer to provider of an application. And so what are the things that we need to build? It's like an employee on a PC in a campus, on an MPLS network, going into a data center, app and data. That's what we've been working on for years. And we're still, working on that. And here, now we got a mobile employee, so they're becoming more distributed, going to apps in a data center. And then I move the app to the cloud, public IaaS cloud. How do I handle with that change, right? So I moved an app from private to public IaaS. I got users out there, and I need to be able to move my security policies with the movement of an application because the app team moved that around. And then I've got all my partner and customer connections, which aren't even, client server. They are, machine to machine, right? So it's a machine probably talking an old crusty protocol to a machine in my data center with a private connection, between the two. And so I have to recognize that most customers have 10, 100, or thousands of partner and customer connections that also need to connect to the cloud. So those are and there's many permutations. Essentially, you could take that matrix and you can highlight any row in every column, and that's a permutation for an interaction type. And what I tell my son generally is knowing what you don't want to do is just as important as knowing what you do want to do. So what I like to do with that matrix is cross out the things you don't want to support, and then you just take them off the table, right? And then just focus on what you do want to allow. Right? So now it's like, okay, that's the problem we're trying to solve. Now let's try to create the patterns. And I've been a L437 services guy since joining Cisco. Like I did my routing stuff, got the CCIE, and then it was like load balancers, WAN accelerators, firewalls, all that stuff. So this is my sort of view of the world, and I try to make these definitions of, you've got a consumer access chain that's in a branch. That has to terminate somewhere. That could be a data center, it could be the colo, or it could be an Amazon VPC, transit VPC. So it could be any one of those. So that's your consumer access chain. And then on the app side, you've got an access chain into the application, and then you've got stuff within the back end sort of bowels of the app, right? So those are the service chains and the places for those service chains. So you break them up, and what's inside the dashed line, that's the Secure Agile Exchange, which I originally called Connect. And I defined the connection as, again, network security, telemetry, and service assurance in a repeatable way. So now that we have that kind of bound, there are patterns here. So like the pattern in a branch of going through service A, B, C, when I terminate it on the other side of the network, I have to go through CBA. Like the order is exact opposite, right? And I can orchestrate patterns. So that's something I can drop on both sides, right? And then going into the server farm, there's also the concept, customers usually bring this up. Inside the server farm, you have micro-segmentation-ish kind of stuff that you talk about or try to achieve. So inter-VM security, or even inter-user security in a branch, those are outside of Secure Agile Exchange. So we try to preserve any segmentation that you might create in the app hosting or the consumer environment, and then carry that through the hub. So usually the engagement is about how do you do things today. So we'll go into each one of these zones. These are all the types of things that you have to connect to as an enterprise. We'll find out how you're doing it today, document it, and then orchestrate and automate. Come up with a master version of what you're doing today, and then orchestrate and automate that. Right? And you can see, the color coding here is green is trusted, so that's you. There's so that's your data center and your WAN. Yellow is semi-trusted because there's a business relationship. So you have some kind of contract with another company, and either you provide a service to them or you consume a service from them. And then there's the internet, which has both business and non-business relationships. And then breaking up into patterns, we have like inbound, you have a consumer chain on the WAN, and this could be an SD-WAN, an MPLS, it doesn't matter. It's coming into the hub here. And then you can go out to the internet. So that would be, a full chain is a sum of a consumer access chain and a provider access chain, right? So two pieces, put them together, that's the full service chain. And then you can say, okay, an employee goes to a web tier in Amazon. That web tier then goes to your private data center and accesses an app. And then that app goes out to the internet to get some inventory or a price or something like that. That goes through this hub multiple times, right? And that's where I'll introduce that concept of telemetry, because in this hub, which has that service stitching layer underneath, we can see everything. So whether you're implementing tetration, stealth watch, whatever the telemetry collection is, I can get all my net flow out of here, I can capture all my packets out of here. Like, the telemetry is there, and then it's up to you, what solution you want to use for the data that comes out of here. But you see everything. So like with a tetration solution, I could sit there and say, show me everything that this partner or customer consumed or went to or attempted to go to for the last 6 months, right? That kind of, because you're associating, a consumer to the providers. And then we can't forget, like I just talked about this one, so the B2B, B2Cs come in, and this is where it's like, okay, they're going to my data center today, now I move an application, and now I got to change the security policy because the application moved to the cloud, right? So we need the flexibility as we start moving apps around. And tetration is actually a good helper there too, because if you implement this, do the tetration, get your application dependency mapping, then when you actually move the applications, because you know what you can or can't move, then you can drop the agent in from tetration and then get security policy enforcement when it moves out to the cloud. So that's kind of a little workflow there. So then also part of the engagement is, hey, let's map out those interactions at a group level. So here you have all the edges that I talked about, the remote access, everything in a table, and you're going to say, who's this is sort of like doing an inventory of what you have already, because we need to build it in an orchestrated way in the future. So green to green, green is can talk, red is can't talk, and yellow is limited access control, deep packet inspection, logging, telemetry, auditing, all that kind of stuff. Service chain, AKA service chain. So build it out. You got your WAN, the same diagram as before, and really the way you look at it is it's group-based policy at an intercompany level, and you're kind of defining what your standards are for connecting to different types of companies, and then repeating those standards over and over and over again whenever you connect to that type of company. So we're kind of get in the organizing phase, right? Not including the micro-segment stuff. So anything that's virtual, I find, is 10 times harder to talk about. So I'm going to try showing you the same thing, like with 12 different pictures, so you sort of get the visuals of sort of what we're doing, and we can drop into a demo halfway when you guys say uncle. We'll drop into a demo. So when the first person say uncle, we'll drop. But taking all those zones and laying out, you have service chains, and just remember the customer with you the other day, like IPS is everywhere. So everything that's coming in has to have an IPS. So their service chains are a little bit different, but we document those. This router here is generally shared. So this router, that router, the B2B connections and the internet egress connection router, those are usually hardware ASR routers, for a large enterprise, 10 gig or higher, and it's shared across many of these zones. And everything comes to this sort of routed core, which could exist in a colo, and inbound, what we're going to do is create repeatable service chains. Now, the first thought usually is that these virtualized repeatable service chains are going to be big shared virtual service chains. So like one customer, I have 400 partners. The first thought would be, I'm going to get an ASAV that's 4 gig for this spot right here, or whatever the firewall is. And I'm going to scale it up to 4 gig, and we'll put the 400 partners on that 4 gig firewall, and all is good. However, when you start virtualizing, you realize that you could turn the most frequently changing firewall, this one right here, where you have your access lists to permit a partner or customer to get to specific apps. You could do one little firewall for every partner customer. It's a microservices approach to infrastructure, so that I have a tiny, 1 vCPU firewall for every partner and customer. And then if I want to make access list changes to that partner customer, I can do it in the middle of the day, because the impact domain is just that partner or customer. And so I can apply that approach to all my partners' customers. I can do it to my publicly facing applications. So if I wanted to make an F5 iRules change, or an AVI, since we're going to resell them, I'll say that, an AVI Networks rule change, I can do it in the middle of the day, because I'm only affecting the one app, because I'm doing a teeny tiny 1 vCPU load balancer firewall per application. Does that make sense, right? And then, of course, I got a fabric underneath all these virtual firewalls, load balancers, web application firewalls. So I need to create this service chain in my fabric underneath the virtual machines, right? So another one would be AWS. We'll look at that later, but you can create a virtual firewall router pair for every VPC, virtual private cloud, you connect to. So now you can be agile between your dev virtual private clouds and your production virtual private clouds. So just see if you guys are awake, and also information for myself. How many people are already in AWS? Developer, well, okay. Just say already in AWS. Half, maybe, 40%. So really, if we put this in the enterprise DMZ, it's it's just a virtualized orchestrated automated DMZ. If we put it in a colo, it really becomes an on-ramp to the multiple clouds you're consuming, right? And also provides connectivity between the clouds within the colo facility, right? And you get direct connections into them. Yep.
Talk about it. Is this like service?
That's a really long question to repeat. So what is this is the next section. In a demo, but essentially from a physical standpoint, this is Nexus switches and these cloud services platform 2100 hypervisor appliances. which I'll get to show you. So physically, that's it. Software-wise, it's software load balancers, firewalls of your choice, right? And then NSO, Network Service Orchestrator, which came from a TLF acquisition, to orchestrate, configuration across multiple devices to create an end user service that is repeatable, just with slight modifications each time you deploy it, and then you offer that in a service catalog. So does it matter which Nexus? With NSO, it doesn't matter. So there's nuances, and we can spend literally an hour or two, or days, 1 or 2 days, discussing the pros and cons. And I'll touch on some of them here, and I've tried to summarize some of them. But even from Cisco, you could have Nexus. We've done it both with customers already, Nexus standalone and NACI, right? So the beauty of NSO is it will talk to anything you want it to talk to. And it's really, there's a process. There's a session tomorrow. I'll have the session called out on the orchestration piece and NSO, because that's literally another, big session. But you're essentially taking NSO to create these end user services, and it could be any, and there are pros and cons, and I'll touch on some. So this is that FedEx slide, and I was trying to figure out how to explain this, because what I found myself doing was talking customers out of SD-WAN. And you're like, hey, you're from Cisco, what are you doing that for? But not SD-WAN totally, just the concept of SD-WAN, in a sense that the concept is I connect every edge to every other edge over the internet, right? There's no, it's just everything to everything kind of concept. That would be like the US Postal Service, where you have a mail hub in every state, and there's a truck route that runs from every state hub to every other state hub. Or at least that's the way they used to do it. That's how they were disrupted by FedEx, who had the model of send all packages to Memphis, and then from Memphis, fly them out to the destination, right? 2 different models. Now think of those 2 models and say, if you're going to implement security, and the goal of the security is to make sure that a bad package, which is like a packet, it's like almost the same word, doesn't get to the destination, right? If that's your goal, do you want to put security essentially everywhere in a US Postal Service model, because that's what you have to do, it's at every edge, or do you want to do security just in Memphis, right? And that's kind of a trade-off, which it doesn't have to be one or the other, it could be both, and we'll look at the topologies, but that's conceptually the difference. So if you look at the hub and spoke model, which for security, central when I can, distributed when I must, and I'll cover that. It kind of looks like this. So you take the WAN, which could be 10 sites, 100 sites, 1,000 sites, or 10,000 sites. That's the little green bubble up there. Dual home, it's 2 of these hubs that are sitting in colos, and the colos have, your data center becomes essentially a cul-de-sac, right? Now you could have storage replication here, like customers are like, well, does that mean I can't have storage replication? Like, no, you use the colo connectivity when you can, but if you need back-end storage, you still do that, right? So the data centers are dual-homed. Your public IaaS clouds, often 3, the number shall be 3. Public IaaS clouds down here. Your partners, typically 10s or 100s, up there, and this becomes the topology, and now you've got, quarter apps in one public cloud, quarter in another, and then a quarter in your data center, just to be an even distribution. So this becomes an ag layer, and you pull like a 100 gig connection to your private data center, which is now mostly a cul-de-sac, right? And that's, the more apps you put in the cloud, the more this topology makes sense. And the core connects your colo hubs rather than your core being rooted in your data centers, right? Because your data centers now have a shrinking percentage of your apps and data. You guys are giving me some blank stares. So it's like, any questions? Okay, right? Now, when I have this, the ones that have been doing this for a while, they realize, they're like, wait a minute, like, what else makes sense to put there? Like a tetration cluster. I'm collecting data from my data center and all 3 clouds to one place. Where should I put it? Should I put it in Amazon, which we now offer, or should I put it in a colo, right? Because it's collecting data from my private and 3 public clouds. It makes sense to go in a colo. So I have another like pharmaceutical customer that's putting their Oracle databases in the colo because they have application components across all the places that need to consume Oracle, right? So they put that into colo. So as you start going through this and you have the network that's rooted in a colo with a bunch of distributed apps and data, this is a sort of a shopping list of stuff you end up saying, you know, what makes sense to go into the colo? Message buses, API gateways, DNS servers, Active Directory, voice call control, like management and orchestration products. Some even virtual desktops in a way, because you got your display protocol coming in. How many people do VDI? So I used to do a session on that. So it's still a good number, like 20%. So you got, you know, the display protocol coming in, and then those virtual desktops need to access apps across all the clouds, right? So do you put like your virtual desktops in the AWS cloud? Do you put them in your private data center? Well, maybe you just drop them in the colo where they have the best access to everything, right? Lots of topology changes. This is trying to draw, and I actually did draw this. It was while Chuck Robbins was doing a presentation. I was like trying to listen to him, but I was drawing lines while I was doing it. So that's the best way for me to pay attention, actually, because if I don't do something like this, then I'll start doing email and tune out. So this actually helps me pay attention. But you know, you take all these things that we talked about, and if you were to do a VPN model, like connect everything to everything, it's like let's go through some workflows and see how hard it would be to deploy, let's say, a new partner or customer. So you have a yellow thing, and you're going to connect it to a yellow thing, which is a public cloud, right? So you have a semi-trusted partner customer, and you're going to connect it to a semi-trusted public cloud. You don't have, sometimes you do if you're providing equipment, but normally you can't put your security policy in your customer partner. And do you want to trust a public cloud with your security policies? So if you're connecting anything but green to green, you know, you guys have to control the security in between, and you can't unless you have a place in the middle to do that, right? So anything that's not green to green, you need a place to do your security, and this becomes it. So, and the workflow for deploying a partner is, I got to put the right VPN tunnel to the right place, because they may only be consuming an app in AWS, and I don't want to put tunnels into all 4 places, my data center and three clouds, because I'm actually increasing their security risk by connecting them to a place that doesn't have the application they want to consume. And then when I do connect them to where the app is, so my VPN and tunnel is dependent on where their app is, I need to put the security policy in the right place. So it gets very complicated when you start trying to connect these semi-trusted things together. So you can also end up in a hybrid model where you have network access control in a branch for like PCI if you're collecting credit card stuff in the branch. So you'll have some security at the edge, but the goal is do it all in Memphis. This works okay. So, and then there's another view of this, which is more of a data center centric view, and it's like, okay, I've got to connect to all these clouds. All the clouds have different ways of doing networking and security and monitoring and all that stuff. And so you have this point of control for, I almost said it, multi-cloud fabric control. I almost said inter-cloud fabric. Anybody heard of that product? So just do a search and replace. This is like an inter-cloud fabric, but it's like literally like an inter-cloud fabric, not just connecting my private data center to the public cloud. So it is providing connectivity through security services. And again, we'll get to the what, right? So first we've got to say what it does. And for distributed components across multiple clouds and data centers. And so summarizing this up, we've got, you know, trends, applications, and the consumers and the providers of applications more distributed, trend. You're more externally connected. Connections to the, I can look down here. Connections of differing security levels is increasing. And this big, the way I now look at big shared infrastructure, and you guys like BS, big shared, is that is actually our ball and chain. Like big F5s, big ASAs, like those are the things that make us slow. Our app guys, they just build a single app and they can make changes called continuous integration, continuous deployment, CI/CD, to their little app all day long, because who are they affecting if they screw it up? Just them. You go to the infrastructure side, we've got this big shared virtual, you know, big physical appliances today. Can't touch that, right? You got to wait till 2 a.m. to make a change, an I rule change to a single application because it could impact somebody else. It's our ball and chain, and the goal here is to cut that ball and chain off and do CI/CD for infrastructure, right? So that's part of the value. It's one solution, whether you're a private, public, hybrid, approach, because we talked about that at the beginning. It's the opportunity. It's like that do-over that you always hope for. This is sort of it, because like we've been building external connections over 10, 20 years. Like I've helped customers like yourselves on this stuff, and it's all snowflakes. It's really painful, and troubleshooting it, removing access lists and firewalls. We'll talk about all that. So improved agility, reduced risk, because there's more repeatability and control, and you are removing stuff when you get rid of it, and improved user experience. So, and also in the topological view of the world, you have fewer circuits, right, with this hub and spoke model. You have cheaper circuits because you're in a carrier neutral facility where you have access to all the carriers and internet service providers. And it's fewer man hours because you're creating these repeatable patterns for connectivity. Right? So you sold yet? You're like, so what is it? Like, hold it, right? So virtualization, it's a journey. Like often I think of it like if VMware didn't exist, would we be able to consume cloud? It would take us a lot longer because VMware really got us ready to consume cloud, or at least it was part of a journey. So virtualization, and we'll cover this as a closer kind of slide, is really a big step in moving to a more agile environment for our infrastructure, right? And the banking customer that I worked with first, before they even shared their entire problem with us, they came with the request in late 2015 to say, we've got 1,400 checkpoint firewalls that are under support. We don't ever want to buy another checkpoint firewall as long as we live, because all it's ever going to be is a checkpoint firewall. And if I'm only using 10% of it, I can't run an F5 on there. I can't migrate to a Palo or an ASA or a FTDV. Like, it's just this one thing. And I'm like, that's a very good point. Like, if we tried to sell, I got this appliance exchange server, you want to buy it? You'd be like, no, we're not going to buy an appliance exchange server. That makes no sense. So it's that kind of mentality, and they had actually been down the path of trying to do some of this with OpenStack Nuage. How many more polling? How many people have tried OpenStack? Okay, just don't be like. So how many people have deployed and operationalized? Wow, still it's 2. But that's impressive. 2 is impressive, right? So they had been trying to do some of this NFV stuff with OpenStack. So I'll show you how we went in and created an easier solution to get started with virtualization. Where do you want to do NFV? Anywhere you have big piles of physical appliances, which is branch, cord, all these places. So we won't touch too much time on that. So part of the what is the CSP 2100, not to be confused with a cloud service provider. That was a faux pas. It's the cloud services platform, not cloud service provider. And essentially what it is it's been around almost 2 years now. We took Red Hat 7.0 at the time and took the TailF CompD software and put it on top. That was the first product that TailF offered as a company in 2005. It turns any Linux server into an appliance, right? So, from that, all we do then is expose KVM, QEMU process for virtualization. We expose OVS, Open Virtual Switch, but you don't actually have to configure that Open Virtual Switch. I'll show you. We automatically do that under the covers. And then SR-IOV, which is how we get the networking in and out of the virtual appliances that you spin up. And then we add things like AAA, radius, TACACS, role-based access control, all the stuff you'd expect. And what the CompD software does is take all this stuff, puts it in a configuration database, and then exposes it consistently through CLI, REST API, and netconf yang, right? And then when we want to orchestrate this, we can put the TailF NSO software on top, and we can orchestrate the switching fabric, which we'll talk about, the spin up of the virtual appliances, applying a day 0 IP address to the virtual appliance, and we'll get into this some more, and then the configuration of whatever the virtual appliance is to create an end user service. So NSO can configure switches, CSPs, firewalls, load balancers, all that stuff to create end user services. So, software block diagram, a little more detailed. You got everything I talked about, and then you can run off an NFS server. So if you have shared storage out there, your VMs, like in a VMware environment, can be on back-end storage. And it offers some really cool operational advantages, which is you can copy and paste VMs. So if you just want to get started manually and you're like, wow, it's a lot of stuff you're talking about, spin up an ASA, copy that ASA, rename it to ASA1. I'll show you in a second. We have time. So that's doable. Just copy and paste a VM, and we'll get through the patterns. And then you could also do that with a box. So if you have 30 routers or firewalls or whatever running on a single box, it fails, put a new box in, paste the config, all the VMs come up because their image is actually on back-end NFS storage like you would be in a VMware environment. But you don't have that operational model to copy and paste and spin up VMs in a VMware environment. So hardware-wise, like the what, getting into more what, is a UCS server. You can configure the processors, memory, network interface cards, which are Intel-based because we're doing hardware power virtualization from the CSP to the top-of-rack switch, so the top-of-rack switch can stitch together services. So you can pick that. C220, C240, more PCIe slots, more cores. We're currently shipping up to 40, anywhere, it's a 16 to 44 core range. We're going to be shipping the new Intels with 56. So literally, you can go in and put 50 to 100 like ASAVs on a single server. Like that's the kind of density, if you're running like 10 meg firewalls, right? And we'll go through the use cases in a second. So networking-wise within the CSP, and now we're starting to attach to the switches. We have released features in the switches to support some things here that I'll cover. So you've got three ways of attaching a virtual machine that is spun up on a CSP to the top-of-rack switch. Now, this is probably a good time to cover overlay networks. We're not doing overlays in the CSP, so you're not creating like an NSX, overlay network in the CSP host. The goal of the CSP is to spin up a VM and connect it to the top-of-rack switch, and then you connect them together because these are network-intensive VMs, not application VMs. So SR-IOV has no CPU interrupts to get a packet from the VM to the network interface card on the CSP. So there's three ways to do it. OVS bridge, let me get this out. So you've got an OVS bridge, which is many-to-many connections. And what I use the OVS bridge for is my management network, right? Because it's low bandwidth and it's pervasive. So every VM, the first interface, make it the management network, connect it to OVS, and put it out to an out-of-band manager. The second thing that I use is SR-IOV. SR-IOV is used for the data plane interfaces of the VMs because they are high traffic volume, and we get the packets out, no CPU interrupt to the top-of-rack switch. And then the third one, which is rare because it's a one-to-one mapping, but it's kind of cool because you can spin up your capture VM appliances here. So if you're using a NetScout or a VNAM, or even now we're shortly a tetration appliance, which is capturing packets, you can spin up a virtual machine, PCIe pass-through, connect it to the top-of-rack switch, and then collect span traffic, and it'll just pass all the traffic through to the VM. And new troubleshooting and operational models are possible because rather than doing ER spans from where my problem is to where my physical capture appliance is, I can spin up virtual capture appliances close to where the problem is and make it transient. Like you could just spin it up, create the span locally on the top-of-rack switch that has the problem, use that capture appliance, and then blow it up when you're done, right? And that could also be offered through NSO because that is really just a configuration thing. You could create a little portal that says, which top-of-rack switch, which port. And it'll go there, spin it up on the CSP, PCIe, attach it to the span port, you collect the traffic, you use it, and then you blow it away. Or it could be persistent, but there's operational benefits. So as I start spinning up these VMs, I've got my first VNIC 0, which I'll show you in a CSP, we call it VNIC 0. I put this on the OVS, and on every CSP, because I create repetition between the CSPs. It's this config to connect like the management interface to my out-of-band management switch, right? So this is just kind of a standard. So every time we spin up a VM, there's one interface created for management. We always connect it to, it could even be a LAN on motherboard, 1 megabit per second interface and straight to the out-of-band switch. Now for the data planes, we go SR-IOV. And there's 2 options for SR-IOV, and this is like the first kind of like switch integration nuance. So this would be, I'm doing a VPN connection. I actually have a customer that does this. So you got a firewall, a VPN, a firewall, and an IPS. That's my service chain for connecting to partners and customers. Just, it's common, right? So I can put them in the same CSP, and one of the customers has an approach of, because they're still thinking hardware approach, so they have pods that they spin up for their external connection customer partners, and they do 60 partners, customers, and then they build another pod, another 60, build another pod, another 60, right? And they do that not because of the scalability limits, but because they don't want one failure to impact more than 60 at a time, right? So they do this repetitive thing. Well, here I could do the same thing with CSPs. I spin these 2 up, create the same services, active standby in 2 CSPs, and then I use the switching within the CSP. So if I do virtual Ethernet bridging mode with SR-IOV, I'm creating a scenario where if I connect, and it's one physical interface, even though I drew it like many lines, so if I connect these with one physical interface out of the CSP, 10 gig or 40, if I have the same VLAN hitting the same physical interface on the same CSP, it automatically bridges in hardware. So I'm creating a scenario where the traffic comes in. It's like the God box for extranets, right? You come in and you're getting multiple services in one physical box, and they're just bouncing back and forth, and then it comes out at the end, right? So this is like a pseudo virtual physical approach to the NFV. Does that make sense? So this, yep. Correct.
No interrupts, I can go fast in and out of the box. And I'm taking the firewall, the back support, all those components support.
So it's SR-IOV when it can, and non-SR-IOV when we must. So we do use OVS sometimes, but right now we're batting pretty good, like the vendors supporting it. All you have to do is have the Intel NIC driver in the product, which most of them do. Sometimes they don't, and if you ask them to, they'll put it in. And we are working on a 4th option, which would be OVS DPDK, which is not as performant as SR-IOV, but not as dependent on the VNF. So yeah, all this stuff is so it's KVM. So I got slides on that, but I mean essentially you just go to that vendor and you're like, hey, do you have a version that runs on KVM? And we run it. ISO, QCal2, raw, OVA. And I didn't call that, it was out on one of the slides. So this is one version, and another customer said, so one was like, oh, this is awesome, it just goes into the box, bounces around for a while, and comes back out. So another customer said, that's terrible, because you guys are all different. And you're like, hey, we want one point of visibility and control being the switch. So even if it's bouncing back and forth, we want you to force the traffic out to the top of rack switch, where I get all my MIB2. I can even do ACLs, like I can do stuff in the switch. So VEPA mode, which is something we just came out with on ACI, will be in standalone, getting into your switching thing, is a way that the CSP can say, hey, I know I'm sending you traffic on VLAN 11, and it's going to come right back because it's, there's 2 VMs here on VLAN 11. Just ignore the fact that you'd normally drop that traffic and send it back to me. So it's a way for the CSP to tell the switch that normally you would drop the traffic that goes in and out the same interface on VLAN 11 to forward it, right? So that's an SR-IOV integration that we've done first in ACI and just because of the timing of the releases and subsequently soon in Nexus. So what's also cool, and this is just kind of stepping on it with SR-IOV because you brought that up, is it's cool because the infrastructure team identifies where the VM is going to connect to the switch. So the infrastructure team tags the VLAN in the CSP, and then if you log into the actual firewall load balancer or whatever, it's just a bunch of interfaces, right? So, and you turn on, that's like the CLI, and you know, anybody want to just see it? Demo, yes, like nods, yes. So, you know, some configs here. These are two, I don't have these on there, but I have SR-IOV that I'll show you. These are two VMs. That's an AVI Networks VM doing SR-IOV. And that's a WSA, which, like the comment, doesn't support SR-IOV, so we implemented with OVS, right? And this is actually a deployment where it's AVI load balancing a bunch of WSAs on an internet egress connection, right? This is the workflow. We'll kind of talk through this with the demo, but it's like, hey, just go download the image. Well, first check that I have a KVM, you know what your performance is, download the image and create the right size VM, which we'll just go do pretty quick. So if the stuff hasn't failed, so this is the dashboard of the CSP, right? So I actually have a graphical user interface into a cluster, right? So there's n number of boxes, and I'm going to spin up virtual machines and attach them to the top rack switch. So I've got 2 VMs running on this 13 cores, so they're 16 core machines, and I have 1 core for the CSP management, and then I got, you know, whatever number, 15 more cores to use. I won't go into all these tabs, but essentially from a cluster management configuration, you've got your set password, the host configuration, so that's just particular machine, the users. So if I go into user, yep. Yep. How's that? Now how do I? Okay, thank you. Well, it's still, so is that, should be fine for now. So anyway, yeah, the user, you know, maybe I'll click on that one because there's stuff here. So I go plus, and you can see my 3 user types. So I've got operator, read-only, I've got administrator, spin up VMs, and configure the CSP, and then I got a virtual admin that can just spin up VMs, right? That's all exposable through, is that a word, exposable? Through the AAA here, which you can see TACAX radius, and I can go in and configure my authentication for those roles that I just showed you, right? And then you can see some of the other stuff, SNMP, but NFS is, I can have many NFS servers, but that's where I have my shared storage. That's also where I can put my repository, my master boot images. So I'm going to reuse my ASAs, my F5s many times, boot them up, and then connect them to the network. So let's, the dashboard, I won't go through all these views. So here I can look at any particular node and then choose, like, you know, particular appliance. Don't be alarmed if VNFs are 100% CPU. That's what they do across the board. And, or memory, actually. They consume all the memory right up front. So let's just go to repository and deploy services. This is kind of hard. So you can see, you know, APICs, big IPs, firepowers, like all kinds of stuff. I have, you know, ICE, Elastic Services Controller, ASAVs, all kinds of VMs down here. So this is my repository of images. I can upload them through the CSP interface if I want to, like, manually just upload a browse something from my desktop and throw it up, and it'll distribute the images across all the CSPs in the cluster, or I just drop them into my NFS server and they're all available here. If I want to go deploy a service, it's hard. I got two services running here, but I'll walk through and deploy like a really quick tiny VM just so you see the interface. We'll do a quick GUI demo, then we'll do CLI, then we'll do REST API, right? And there's a session tomorrow in the morning on doing it through NSO. There's also a lab tomorrow afternoon to spin these up manually and then do this through NSO. I'll also show you these templates, which are cool. So if I go into name a service, I'm going to spin up this tiny core, which is just a one interface machine, and I'll do a tiny GUI, spin it up on the CSP1, go pull an image here, so it's tiny. I can pull it off of NFS, or I can pull it off of local storage, and then, you know, one core, 4 gig of RAM, 2 gig of RAM, 4 gig disk. Just leave all the stuff alone. So now I got to connect it to the outside world. So literally just go in here. It's external. Pretty much everything we do is external. And I go pick a NIC, and I know it's my first gig NIC. Hit submit. And if I need to do a extra storage volume or a serial port, I could do those there. Hit deploy. So this is spinning up a very small Linux image just quickly. It'll bounce back to the display of all my VMs, and I just had the ASA CSR here, so I have tiny GUI, and I can log into that here. So you have your console access through no VNC, and you know, you can see I'm like booting up this little thing, which could be a network VM. So that's all well and good. So if I go over to the CLI, and I do show, it locked up. New window, basic. It must be a network problem. So this I can make bigger easily. So SH, admin at. So I do a show services, right? And now I've got that tiny GUI there. You know, that's what the name was, and I have my ASA and my CSR. So I can do a show run. I'm going to make this a little bit smaller. Just like you would on a router, right? You got all your options. I can pipe. So begin, tiny, right? And I just get, you know, what that VM looks like here, tiny GUI, and that's what the tiny GUI is. So I can go into config mode, say service, tiny CLI, and literally go grab all this config, which is the description of it, and the boot file name, and paste it, and then hit, you know, commit, and show service. Now I've got tiny CLI booting up. Now I can take the same thing with the ASAV. So if I go show, run, begin, there's my ASA config. So, oops. So let's go back up to the ASA and shrink it down so it fits on the screen. So notice that I've got a 3 interface, so that's the CSR. Here's the ASA. So here's the ASA. I've got my 1 vCPU, couple gig of RAM probably. It's running off of NFS, right? So I can copy and paste this thing. I got a management interface here, and then I got 3 interfaces, VLAN 101, 102, 103. These are set in the CSP, and it's going to map into the Nexus fabric. And so if I look at the CSR, notice that its first NIC is a VLAN 103. So VLAN 103, VLAN 103, those two are connected via SR-IOV and a hardware NIC just because they map. So I just service chained an ASA and a CSR just because I mapped the VLAN 103s. And I can literally do the same thing with the ASA, so I can go config, you know, service, go up there and get the ASA config, right? So everything from here to there, copy, oops, service, ASA temp, paste, commit, end, show service, just created another ASA. Now, normally I would change the VLAN mappings if it was real life, but so here you have the original ASA. If I log into this, just so you guys see what it looks like from the inside, connect. You can put passwords on the VNC stuff. So if I hit enter here, last time, okay, so that's still there. So essentially I've got management 0, that's the VNIC 0 config. I've got 3 10 gig interfaces. That would be my outside, my inside, and my cluster link. And literally, like I can use NSO to spin these up. I can copy and paste them. I can script them. I can also use Postman. Or any other, REST API approach. But literally, the create tiny REST right here. I've got, my password. Here, it's admin. You guys can see that. Exactly what I had just done. Now, this could be an ASA or a CSR. Doesn't matter. And the VNIC, and like my joke is, this is less than 140 characters. So even Trump could tweet a VM. Like that's how small this API is. So hit deploy, it goes created. If I go back over to the user interface here, I've got tiny REST booting and I can log into that. So that's how easy it is, either through CLI, GUI. Oh, and the other GUI approach is, let's go and look at my saved service templates. So what I typically do with any of these VNFs, if I'm going to start doing this stuff manually, is I just go create t-shirt sized versions of my ASA, my F5, my Palo, whatever it is. So I can go in here and say ASA small, and all the metadata, the gigabytes, the CPUs, everything, the network configuration for exactly, that VM type repeatably is created, and I just need to change, these, the VLAN numbers right here, and the name, right? So that's all doable there. So back to our regularly scheduled program. So that's kind of the process we just talked through. And so on the deployment side, we're going to try to go through a bunch of sort of architectural slides here, so you get a picture of how we're creating these connectivity patterns repeatably, and then throwing NSO on top if you choose to go that route. And I have slides like per zone of the Secure Agile Exchange, and sort of the design concepts per zone. We may not cover them all. I may just do the Cloud Connect zone because that's popular, and I may skip through some of them. But you guys will have the slides for that. And there's a lot of hidden slides too. So I'd ask them to keep all the hidden slides in there, so you guys have that to take.
NSO is
not required. Yeah. So especially if you're a customer that's going to go big shared virtual, and you want to continue to use your Cisco Security Manager, your F5 Manager, you can do all that and operate it just like I just showed, right? Now, if you want to go the dedicated virtual, like I want to have a firewall per partner, and I've got 100 partners, and I've got now 100 firewalls, that's when you want to bring in NSO for the repetitiveness of that. And there's also some cool things you can do with security management that we won't be able to cover today, but there are things. So that's actually a big fork in the road. I was going to get a graphic, so just imagine, if you will, a road with a fork. Because the fork in the road is, am I going to do big shared virtual for any one of these sort of connectivity domains, or am I going to do dedicated virtual? And it actually depends on the thing you're connecting. So if I'm connecting the WAN, I'm going to do big shared virtual. WAN accelerators, I'm going to do big, right? But when I'm connecting to virtual private clouds, partners, customers, and applications, that's when it actually makes sense to do dedicated virtual, because I have frequent change happening. And then I can limit my impact domain of changes to just that thing. And I now think of those things as managed objects. So like a virtual private cloud is a managed object. A partner is a managed object. And how do I want to manage those things? And I create the repetitive pattern in NSO to create the connection, network security, telemetry, service assurance to that managed thing. The other choice is shared storage, direct attached storage, technical differences. So as you start rolling this stuff out, you start thinking about different architectures and the implications of those architectures. So this is one, which is I'm going to take a bunch of CSPs, and it's typically only about 4 switches. Again, the switch fabric. Could be ACI, Nexus. And what I do here is I dedicate, because we have this mentality of, hey, I need hardware segmentation, right? So I create that, but then I still virtualize. So I'll create a stack for my partner connections. I'll create a physical stack for my cloud connections. I'll create a stack for my e-commerce zone, right? So I'll do things half virtually. So I'm not getting full shared infrastructure. I'm getting segmented shared infrastructure. So this is an approach. We've done this with customers. And this is where I'm segmenting zones. So another way of segmenting is this. I create a CSP compute cluster at a closest to the internet, so the most untrusted. Then I have another CSP compute cluster closest to my internal private network, and then one in the middle. So it's like 3 tiers of security. And what I do is I say, when I'm connecting to the Nexus switches, I make sure that only certain VLAN ranges, so I can't accidentally, and this is if I'm operating manually, I want to prevent the possibility of a single configuration error causing a misplaced connection. So I got my internet cluster, which is physically only connected to the internet. So when I spin up a VM, I'm making sure that those VMs can't accidentally connect to the inside, right? So there's ways of doing that by creating tiers of compute clusters and different security levels. Now you could take the previous slide and this slide and segment both ways. So you've got 3 tiers of CSPs and compute from a security level and a domain level if you want to get really crazy. But you make the analogy back to AWS orchestrates all this stuff and nobody cares and they're okay with them creating all this network connectivity and nobody questions that. So if you do orchestration and you build the orchestration properly and you test it, you can just do one big shared pool, which we're going to cover next. So repeatability, you create one connectivity model for the physical connections between a CSP, which we just talked SR-IOV, management networks, to your top rack switches. So whether you choose, 4 NICs, 5 NICs, 6 NICs, we could, get into the details of the pros and cons of each, but you could literally put all the little VMs on one physical 10 gig NIC and then just tag VLANs and segment them in the network, right? So repeatability and the network connectivity of the appliance. Then what I realized as I started doing a lot of this stuff was, wait a minute, when you look at the config of the CSP, it's like everything is either a management interface in 1 data plane, management in 2 data planes, or management in 3 data planes. So it doesn't matter if, with the 3 data plane, an F5 has an outside, an inside, and a cluster link. So does an ASA. Wait a minute, the only difference between the config of the VM in the CSP is the boot file name and the size and the VLAN tags. So that's a little bit. But so repeatably, so there's really not much difference between a 3 data plane ASAV, outside inside cluster, and a 3 data plane, F5 outside inside cluster. And you can literally copy and paste, change the name, change the boot file name, spin up the VM, right? So that's part of the pattern. And with this pattern, it's like Lego blocks. So I've got these repeatable VM patterns, and now, the customer request I mentioned, so I had a customer that asked for a 219 interface firewall. I was like, are you joking? So they're no. We have 25 business units, and these business units have networks inside of them with differing security levels. So we literally have 219 different, entities of differing security levels. So we're like, well, can you imagine a change control problem with a 219 interface firewall connecting to all these businesses and the sub-elements of those businesses? Like, that would be crazy. But taking a secure Agile Exchange approach to solve the problem, I take my 3 little VM blocks, and I could build that firewall with 219 two-interface firewalls. So orchestration, spin them up, routed core, just like we described. And now I can make changes to that segment without impacting the others. It's only that segment and whatever they're going to, because I need to open up the two holes. So I would, two things, I get flexibility, so it's even better than having that big Uber firewall, right? Usually, at this point, somebody asks me a question about pricing, but we'll work through that. We'll save that for after in a Q&A. So I try to beat you guys to it. We're working through that, and actually, so are all the other vendors. So, the concept would be, yes, the price will be nearly equivalent for 400 10 meg firewalls as it would be for one 4 gig firewall, right? And that's the short answer. So you have 3 VM types, and then you have 3 wire types. So it's like the number shall be 3. 3 shall be the number. And the 3 wire types are here. So you have 2 VMs, virtual wires, because when you go into colo, you're going to wire everything once, and you're going to keep reusing it and using virtual wires to create these service chains in the switches. So you've got 2 VMs on the same CSP. I showed you that. I didn't actually do the ping, but the ASA and the CSR, VLAN 103 was configured in both of them. It switches within the NIC. So that's, configuration option number 1. Second option is 2 CSPs and 2 VMs on the same switch, which is just, mapping a VLAN through the top of rack switch. NSO can do that. And then the third one is two VMs that I need to stitch together on 2 different CSPs on 2 different top of rack switches. And that gets into, I need VXLAN, right? So I have to do a VLAN, incoming interface, incoming VTEP, outgoing VTEP, outgoing interface, outgoing VLAN. Again, all orchestratable with NSO. Or you guys can do it. And these virtual wires across the switches are static. It's not like we're doing a VTS or a ACI environment where you've got VMware and other virtual management domains running on top of your application fabric. We're spinning up the VMs, we're putting them there, we're creating these wires, and these wires are going to stay there for the life of the VPC, the partner, the customer, the app, whatever it is. These are long-lived things. You're not chasing them around because somebody did a live migration somewhere. So, yep. So this is hardware. So when a CSP spins up a VM, we're using SR-IOV, which is para-virtualization to the physical NIC on a CSP. And I did remove some slides on that topic because I thought I had a 2-hour session and it changed an hour and a half, and so I hit a lot of stuff. But there's no CPU interrupt to get the packet out of the VM to the physical network interface card on the CSP into the switch. So it's no CPU interrupt for that. Yep. And hardware segmentation, in a sense, I tag these VLANs and it's like hardware. So this is what I kind of showed you, ASA, CSR, copy paste them. That's a 2 interface SR-IOV config. That's a 3 interface SR-IOV config. Other than that, the same. And then the VLANs map, right? So this is the virtual wire number 1. I'll skip through this, but this is a good place to talk about the demarc. So when we spin up these service chains, you guys have to connect them to your networks, whether it's, it's coming in from the internet and it's going to the core of the Secure Agile Exchange, or it's coming in from the internet and you want to connect it all the way to the VPC if you wanted to do that, right? So you can do edge-to-edge chains, or you can do edge-to-core chains with the circle diagram I showed you before. So in order to keep a demarc, the service chain starts with a VRF in a Nexus switch, and it ends in a VRF in a Nexus switch, and it could even be the same Nexus switch, but that's all a placement logic, right? So does that make sense? And then outside, so we create all the links inside the chain, and then whatever you guys, ERGP, OSPF, BGP, whatever you're doing outside the chain, you guys can either manually configure that, or we'll bring in services to help to automate, the external connectivity, right? But inside the chain is what we're working on first. So this is just an example of the shortest chain you could possibly have, which is just a firewall between 2 networks of different security. So it's a VRF, a firewall, and a VRF. Right? So if you take that, build out that extranet connection, or this could be a cloud connection because they're almost the same. So you've got, VRF, 3 services, the CSP VLAN mappings, and this is what you're creating across multiple switches. Everything's either a 2 or 4 port bridge. I think the next couple of slides show that. So the VXLAN overview, and you guys talked about it, but it's on the previous slide, it's literally, you know, VLAN on this interface, this VTEP, this other VTEP to the interface, and a VLAN. And NSO has the ability to do VLAN, VXLAN resource management. So it'll pick the local VLAN on the top rack switch and global VXLAN, you know, across the fabric. Right? So you're not having to do that. And then so conceptually, we've got the CSPs, and we're tagging them at the edges and creating the tunnels across. Now you could do this the original VXLAN way with multicast. You can do BGP, VPN. However you want to create this, and we can do it in NSO so it's fully orchestrated. And make it multi-tenant, because this is really multi-tenant, because all these data plane interfaces coming in off the CSP, we create these virtual wires, so the data plane of all these VMs is fully ships in the night. So if you have multiple business units, the management interface is shared, so you can provision across all your tenants, but the data plane interface is totally segmented. Could be Coke, Pepsi, you know, kind of thing. So I wanted to get through this concept here. This is, okay, I got 3 different chains. I got my VRFs on the edges. This is an e-commerce. It's an external connection, so it could be a cloud partner or customer in the middle, the blue one, and then an internet egress chain on the right side. So 3 just, you know, examples. And this thing, you know, the green would be terminating in the core of the secure Agile Exchange, and the red's on the outside, so trusted, untrusted to trusted. And, you know, there are patterns that we could talk about as far as like opening up holes in firewalls and the VIPs and the load balancers. Like there's other patterns that you can orchestrate across the service chains. So this is what you end up with. This is it's like the clean slate, right? So you're starting out, you've got NSO. NSO is sitting on a management network that touches all the CSPs. You've got your NFS also on a network that touches all the CSPs, so you could spin up these VMs and they're operating on a backend NFS shared storage. CSPs can die. You can copy and paste. NSO can drop them anywhere, and they just come back up off the shared storage. The other option is NSO has all the configuration in it, so if I don't use backend storage, NSO will create the config based on what's in its database, right? And I'll touch on some sessions you guys can go to get more info on how that happens. So I have these 3 service chains I'm going to create across this cluster. So this is the fully shared model that I talked about before. So this is, I'm not going to like segment it by security levels. I'm not segmenting it by, you know, extranet, cloud connect, you know, blah, blah, blah. So this is, I got to place my first pair of VMs. So what do? I have a placement logic, which is most available resources minimally meets the requirements of the VM. Put my primary firewall there. The backup firewall minimally meets the requirements, or sorry, most available minimally meets the requirements, not on the same CSP as the primary, not on the same top or X switch as the primary. And a top or X switch information is available from the CSP, both through the CLI and through API. So LLDP is provided, so you can make sure you're not dropping it on the same top or X switch. Right? Anti-affinity logic. So I just keep applying that same logic every time I drop a VM in, and then I lay out my virtual wires. So I'm picking my infrastructure placement based on compute resource availability, and then I spin up the virtual wires after I place the VMs. Make sense? Right, so they can, your service chain could be sitting out there like just dangling. It's not connected to anything, right? And then you're like, pop the network up from underneath, and the service chain VRFs out the side, right? So same thing with the other service chain. Again, a shared compute model. Now, I compare this to trying to explain to you what happens under the covers in the Amazon cloud. So if you feel lost, this is the equivalent. So it's like how the cloud would work underneath, but at the end, you're going to present, you know, these service chains as end user services out of a service catalog, right? So connect them all up. Now I've got a VRF, you know, for VPN connection, cloud connection, whatever it is. Now I spin up my next chain. Again, active standby, go through the list, and build out my virtual wires, and I've got another chain. And you can keep filling up the infrastructure. And what's also cool is if I have a partner or customer I added, I spun up a chain for that. You know, this chain is 3 cores times 2, so 6 cores. I spun up a chain, I get rid of that customer partner, right? I blow away that infrastructure. So I'm not going into that big shared firewall and trying to surgically remove, you know, access lists in that infrastructure. I'm literally getting rid of the infrastructure, and then the resources consumed by that can be used for something else, right? So, and there's a concept here I created this slide for, is the frequency of change. It's good to keep this in mind when you're deciding what you want to orchestrate or not orchestrate. Spines barely change. Top-of-rack switches with the VXLAN fabrics, changing a little bit more often because you've got all these wires going on. Spinning up of the VMs just happens once, sits there and stays. The configuration in the VMs changing a lot more. So, you know, using NSO to manage access list changes is an option, and there's a lot of benefits in doing so, but that would be like a whole nother session. So there's another concept that's very important here as you start doing dedicated virtual services in this, and again, it's for partners, customers, virtual private clouds, and applications and e-commerce zones. It's a concept of scale up, scale out, or scale down. And you know, this is AVI networks. When they scale down, one vCPU can do a gigabit per second of SSL traffic with 2K keys and 2,000 session setups per second. So like awesome performance on generic x86. And then so as you scale the number of these load balancers, 1 per app, you're really not consuming that much resources. So my new line is scale down is the new scale up, right? So I have lots of little things, I'm orchestrating them, and I have small impact domains, and I'm making frequent changes, continuous integration, continuous deployment. The equivalent of the ASA is over here. Now we could actually fit 4 to 6 ASAs at 100 meg on a core. So, you know, I go into a customer, I'm like, you can't believe how many of these little ASAs you can spin up. It's kind of from that history of being a PIX. Like it was like really tight code. Now we made it fatter, but it's still like really light code. So you can really consume a lot of these and not consume a lot of resources. So so we do still get into the scale up approaches. So, you know, there's some slides in here on what we offer in the Nexus standalone switches for scale up. So if I want to scale up my AVI Networks load balancers, I can ECMP load balance into them. I can also do ITD, Intelligent Traffic Director. If I want to do IPSs, I can do Smart Channel, and this works for virtual appliances, so that's why I'm covering it here, because all these things work with a virtual approach too. And then I can do Nexus Data Broker for the capture VMs that I talked about, so I can load balance conceptually a bunch of tetration capture VMs or Gigamons or VNAMs or whatever it is. I can load balance into those too. So I have the capabilities on the rare occasion you need to scale up to provide scale up for virtual appliances. These are cheat sheets that I created for you guys to take away, and it's really, it gets into, you know, I've got routed and bridged services that I got to insert, and then how do I best load balance them in what modes with which technologies. So this is that Nexus cheat sheet I've tried to create. So if you have a load balancer and you want to scale it and it's in routed mode, you use ECMP. You know, if you have that load balancer, and you can also use Intelligent Traffic Director. You could use Smart Channel for bridged, right? So this is a cheat sheet of my VM is this kind of thing, and my fabric is, you know, routed, bridged. What do I do for scale out, right? Now we have a new technology that was delivered in Interop, or is announced in Interop. It won like Best of Interop. It's called Katina. So I just, you know, this would be a whole session in and of itself. But conceptually, I can take all the complexity of the service chaining, which you still would have to do in the VNFs or the VMs, which is the routing, you know, across the service chains, which NSO will take care of you if you're using NSO. But another approach, which is now available in Nexus, is I basically just tell the VM to have a default route to the fabric, and this configuration will handle service chaining of multiple VNFs, virtual or physical, and the scale out of those VNFs with keep alives in the fabric, right? So I can create service chains and we're implementing this with VXLAN right now. So we're taking this capability, which is doing service chaining, taking all the routing config out of the VNF, and create this service chaining capability in the fabric. So this is like a whole nother, but just take a look, both for physical and for virtual, to creating end services and scaling each service, routed or bridged, on a per service basis. So the question is what platforms, and it's available across all. Katina. And this is that cheat sheet, which I almost all completely filled out, but you can see, like, when you start doing these service chaining capabilities in the fabrics, you have to look at, how do I select the traffic? How am I going to do balancing? And what are my balancing methods? Can I do NAT? Can I do sticky, and how I do all that stuff? So, this is a cheat sheet for, but again, if you scale down, you actually don't need most of this stuff. It all goes away because you're using many small to scale up, right? So, but the service chaining, that's applicable. So the capability that we're delivering in the first version with orchestration is basically, getting rid of your requirement to plug in cables and configure physical, machines and plugging them in, racking and stacking them. And then we'll configure the VM chains, connect all the stitching of those chains, and the edge verse, and then you guys do the configurations inside the VM, day one. If you want to do NSO on top of that, you'd have to take a class or hire our services to help you do the full orchestrated piece today, because everybody's different. That's a problem. Routing outside of this domain is different for every customer, and how you configure your external connections is different. So the process is build the master config, take NSO, suck in all the configs, variabilize or parameterize them, and then expose the parameters or go get them from IPAMs or whatever, and then repeatably deploy under a catalog. So in this section, because with the NSO, I was going to just cover it at a high level, but there's a session tomorrow on it, and I have talked about it throughout. I'll just cover the Cloud Connect zone, because this kind of highlights sort of the approaches in all the other zones. And a lot of customers are interested in this Cloud Connect today, so I'll cover it. But it applies to the extranet. It applies to all the other things. So when you start saying, hey, I'm going to deploy connections into Amazon, you probably start out with a physical infrastructure on your side that's shared, and you're connecting to multiple VPCs. So you have implications here because you have prod development. Dev changes often with low availability requirements, and prod has high availability requirements and doesn't change very often. And now I put those on a single infrastructure on my prem to do a VPN tunnel out to the cloud. So that's the story here. So I could say I have two different requirements, and I'm starting to microservice, but not entirely. So I spin up one infrastructure for prod, one for dev, and now I've got more flexibility, but I still have impact domains across multiple VPCs. So why not do exactly what Amazon's doing with an access gateway on their side and spin up a dedicated virtual set of services per virtual private cloud? Now, again, I'm CI/CD. I can make changes. New ALB gets spun up over in this VPC, add the IP, done, right? And you can orchestrate that too, right? So that's the concept. You guys can go through the other zones. Lots of extranet is very similar. So on the, I know we're at time, aren't we? I know it was so fun, and time flew. So there's a lot of value to all this here. Like, you guys have the takeaways. You can read this stuff. But there's risk, experience, cost, flexibility, agility, automation. This 2 slides to wrap up. We'll take questions for those that want to stick around. So this is really a journey. The way I look at it is, we haven't virtualized. You cannot be automated unless you're virtualized. So you can dynamically spin up things and tear them down. Like, if you're walking into a data center to plug something in, that's not automated, right? So you fill up capacity, you grew, hey, I got to go plug something in. That's not working. So we've got connectivity nailed, but it could look like this, which you guys have probably always seen this slide with all the cables. It works. It's connectivity, but it's not agile. So literally, this was a customer I deployed a big data deployment, but this could be CSPs because it's the same exact servers. Like 2 or 3 data cables, power. That's what this infrastructure looks like. It's just clean, everything's repeatably connected, and then you're spinning these VMs up and bouncing in and out of the top rack switches. So it is a process, it's a journey. Virtualizing is the first step, even if you're manually virtualizing. Think of it like VMware 2005, or even 3 for applications. So I'm virtualizing, but I haven't done, Cloud Center Clicker where I provision an entire application. I'm just doing, VMs as a start. And the CSP makes it really easy for network security and load balancing teams to do that with similar operational models that actually benefit for infrastructure. And then as I hone my repeatable models, I come up with those repeatable models, and I either engage with Cisco or figure it out myself. Like NSO, its value is I can create a coordinated configuration across multiple end user devices, to create a single end user service. So that's the value of NSO on top. Once I create that, now I'm just doing repeatable patterns under a single service catalog.